each one is how big? 5 minutes. So that's a nice model. 60 divided by 12. We can say clock, right? So 60 minutes broken up into sections of 12. Each section is 5 minutes long. Nice. Good. It's a good one. What's another way to do it? Could you model it? Could you just break it into parts?
Well, you could do like 6 times 10 and then take away. No, that would work.
Number line.
Could do a number line. If you were using base 10 models, which you have in front of you,
Yeah, I do it differently.
right?
Yeah.
If you think about rods, if I have 60 of them, or 6 rods, which is 60, I can't make it 12 wide if I only use rods, right? So there's my 60, but if I think about taking one of them and trading it for little cubes, I can break that into 5 equal parts and put 2 in each end, right? And I know that that's going to, if I just skip count by 12, right? So I could organize that into an area model. I know that I can't have 6 rods, I need to have length of 12. So length of 12, 5 times is going to give me 60. Okay, that's another way to think about it. Sometimes we use some other strategies. So maybe we'll save those for later. I want to move into kind of a fair sharing notion. How might you do that?
12 divided by 4 and 4 divided by 4.
Okay, that's not 12 though.
Oh, okay, and then 20 divided by 4 and 4 divided by 4.
Okay, can I divide 120 by 4?
Yeah. 100. Well, 12 divided by 4 is 3, so it would be 30.
Okay. So if I was going to model that though, if I took 100, can I break it into 4 parts?
Yeah, that's 25 each.
Yeah, I suppose. But what do I have to do with it? I have to trade it for? I have to trade it for?
10.
10. So I'd actually end up with 12 rods, right? Rather than a flat and 2 rods, I'd end up with 12 rods.
Right.
So we're talking about modeling here. So I could have 12 rods and break those up into 4 groups, and how much goes in each group? 30. And then I have how much left? So I've shared 120. How much do I have left to share?
4.
4. So I can put 1 in each group, right?
Right. 31.
31. So we can fair share using our base 10 materials. Okay? And how we teach kids division, the first thing we do when we start teaching these bigger numbers is through fair sharing. Okay? It's the easiest way to get to this notion. Okay? So I take 120. I couldn't have shared my flat, right, in 4 equal parts without trading, right? So I traded it for 10 rods. Then I had 10 rods plus the 2 rods that I had to start. At 120, or 12 tens is another way to think about it. I had 12 sets of 10, and I gave each group 3 sets of 10 or 30. Okay? And then I had 4 more left to share, so I could give each group 1. So each group now has 31. Is that okay? Good. Okay, how would you write that symbolically? How would you record what you did?
How would you record what you did?
Yeah, how would you write it as a symbol? Like symbolically, what did you do?
Oh, you mean instead of drawing it?
Yeah. You might commonly think that you would write it
124 divided by 4 equals 31.
Okay, you could write it, but if you wanted to show what you did, you might show that 20 and divided that by 4 and put 30 in each group, right? And then you did 4 divided by 4 and put 1 in each group.
Right.
Okay? And this, what does this remind you of? What were we doing before? We were breaking it in parts, right? So this is like using the distributive property. It's not really, but it's like using the distributive property. You can break it into parts. So I can always take each part and break it up, right? And fair share it. Yes,
okay, let's say for example it wasn't like 12 is easily divided by 4. But it wasn't so easily divisible.
Okay.
Like, I don't know, 150 something by 6.
She's on to something here.
How would you, like, would you try to divide 100 by 6, or would you try to, do you know what I'm trying to say?
So what, yes, I know exactly what you're trying to say. You're trying to make it seem like this isn't always going to work.
No, I know it's always going to work. I just wonder how to do it that way.
I'm kidding. Okay. So if I had, you want to do 156?
Yeah, 156, or 154 divided by 6. Or
154 divided by 6.
Yeah.
Okay. Okay, 154 divided by 6. So let's think about that. I'd have a flat, right? I'd have 5 rods, 5 sets of 10, and 4 little ones. Okay? But I can't really fair share my flat in 6 equal groups, so I'm going to make that go away. I'm going to trade it for 10 rods. So now I have 150. So I have 15 tens, and I want to fair share that in 3 equal groups. How much can go in each group? I'm doing 150, and I want to fair share that in 3 equal groups.
2.
I can do 2, right? 2 tens, which is 20. So I can put 20 in each group. So I'm going to pretend these are my little groups down here. Okay, so there's my 6 little groups. They have 20 in them so far. How many of these rods have I used?
12.
12. So 120 of this has been fair shared. Right? Okay. I'm going to write this symbolically in a minute. Let's just do it first. Then I have 3 rods left to share, but I can't share them, so I have to break them into
1.
little cubes, right? So I would change it for how many little cubes? 30 of them. Okay, so now I have 34 cubes to share. I have 6 equal groups. How much can I put in each group? 5. So each one's going to get 5 little cubes. Okay, can we pretend that I've put 5 in each one? And I've used how many of them all together?
All of the 4.
All of the 30. And how many do I have left over?
4.
So I have a remainder of 4. Now,
25 and a remainder of 4.
I have 25 with a remainder of 4. Okay? If I'm in a higher grade, I might take that 4 and break it into decimals, but we're not going to do that now. We'll do that in middle school next year. I swear we will. So if I want to write what I did symbolically, and I think this might be the question you're getting at, is do we ever teach them this?
Yes, that's exactly what I'm getting at.
Yeah, I can think what you're thinking. I'm a mind reader like that.
That's what I think. I'm guessing we don't. I'm guessing we don't.
So here's what I'm going to tell you. What we're going to do instead is we're going to talk about the fact that if I had 6 times something that was really close to 150, what might it be? And I might say, well, 6 times 30, because sorry, that's not what I meant. 6 times 20 or 34 left to share, and then I have to think 6 times what is close to 30, right? Or 34. So 6 times 5 is exactly 30, which is close to 34, and then I have 4 left over. Okay? So how much did I put in each group? 25.
So that was a lot easier.
Yeah, it's easier if you know how to fair share. I would never give that to kids before they've modeled it.
Right.
First.
Yeah.
Yeah.
I'm confused about, because I did my practicum in a private school and we weren't allowed, it was grade 1 and 2, we weren't allowed to stack at all. It was all like work like this.
Yeah. Because grade 1 and 2s don't need to know symbolic. All they're doing is recording what they've done.
Oh, okay.
Yeah.
So when would you start stacking like this?
This would be something I would do with grade 5s and 6s. But I can also do this like without stacking.
Yeah, you don't actually have to have that on top.
No, I just wrote it that way because it's gonna make Evelyn laugh. Because she's like, I can't let go of my traditional algorithm.
No, I'm just wondering, would you ever teach them that now?
Yeah, we still teach them how to do that, but we teach them how to do it by using their thinking strategies and not by saying,
Take the kid, carry
we're
that.
trying to prevent the gazintos.
Right.
Because I guarantee you, there's no child who knows about the gazintos. They are passed. They're highly contagious, the gazintos, and they're passed by teachers to their students. Okay? If we prevent the transmission of the gazintos, we can stop a whole generation of children from getting the gazintos. Goes into.
Oh, I thought you said like
No, like the 6 goes into 1. No, it doesn't. 6 goes into 15. No, oh yeah, twice. No, that's not 15, and that's not 1. That's 100. Okay? So sometimes we might do something like 1248 divided by 6, right? So I might think, well, 6 times 200 is 1200. And I might think 6 times what is 48? So now I know that 6 times 208 is 1248. So I've used my multiplication strategies to do a division. You like that one?
I like it.
Okay? Or I could break it into parts, right? I'll post this on. Okay. If I do 1372 divided by 8, I don't even know if this works, right? So, but if I think 8 times what? Okay, well, I know 8 times 100 is 800, right? And I know 8 times 50 is 400, because that's half of that. Right? You go with me there? So that's going to give me 1200, right? So 8 times 150 is 1200, and that's pretty close to my 1300. So now I have another 172 to think about. And I need to divide that by 8. Right? So if I fair share that, 20 times 8 is 160. So 8 times 20 is 160. That makes me happy. Because then I have how much left over to share? 12. So I got a remainder, right? 8. I can think 8 times what is 12. And if I'm really gifted, what might I know about that? Oh my goodness, it is 1.5 or 1.5, because up here I knew 100 gave me 800. And 50 248 divided by 5 and know how to deal with that. In grade 4 and 5 and 6, yeah, 5 for sure. Because they can model it, right? Right? So I can take 24 tens, put 6 tens, that's 240, and then I've got 18 left over, right? Just fair share. And we want them to know when to deal with remainders, like when do I use a fraction, when do I need another band, right? It's a great question, like you have 80 kids, and each band can take 6 kids, how many bands do you need? And I can't tell you how many times kids will say 13, remainder 2. And you're like, what's the remainder 2? And they're like, well, it's 2 extra kids. Okay, well then don't you really need 14 bands, or are they just going to run the line? Right? You can't really help them in the decimals because parents get really upset when you start sharing them. 2 over 13. Okay, 2 over 13 you get from that one, and 2 over 13 you get from that one. See, one of the things we do with grade 4 is we really learn how to deal with fractions, or with remainders too, like talking about them in context. Yeah. Your question's gone? It was there. It was there.
Oh yes, I did have.
Yeah.
The older grades for mental math.
Okay, just a sec, folks. I know you're all excited to leave, and I swear I'm going to let you leave really soon, but let's just let everyone ask her question.
The mental math questions for the older grades, is that something they'll just discover on their own, or is that something we're going to be teaching them?
When we teach mental math, we teach the strategies. So I might say, let's pretend we're going to learn a multiplication mental math strategy that you're going to take home with you on the weekend and show off to your friends. Okay? So, I'm going to teach you a mental math strategy that you can show off on the weekend. How would you multiply 24 times 15? I'm done. Anyone else?
Whoa! 20 times to be the same.
Same as the what?
Oil.
20 times 10, 10 times 10, 4 times.
Okay, that's one way. 20 times 10, 10 times 2. No. 20 times 10, 20 times 5, 4 times 10, 4 times 5. That's a lot to keep in your head, though.
Is it 360?
It sure is.
24 times.
How'd you do that, Ellen?
How did you do it?
I did 15 times 20.
Okay.
300, and then I did 15 times 4, and because I play cards and
Okay.
I know 15 times 4 is 15.
Okay. That works. That wasn't how I was looking for. That's a good strategy, too. My strategy was this.
Ooh. Nice.
Okay? What did I do? Why is 24 times 15 the same as 12 times 30?
Because half
I have one and double the other. In fact, this strategy is called halving and doubling. And if I can make the problem simpler by halving one and doubling the other, what I'm really doing is factoring out a factor of 2, right? And multiplying that 2 by the other number. Okay, and that's what we call here's another new property for you. This is the associative property. If I have 12 times 2 times 15, it doesn't matter if I do 12 times 2 first or if I do 2 times 15 first, I'm still going to get the same answer, right? Okay? So I can take a factor of 2 out of 1, divide it by 2, and take that 2 and multiply it by the other one. And so 24 times 15 is the same as 12 times 30, and that's easy as 12 times 3 times 10. And that makes you happy, doesn't it? So, to answer your question, we hope that the strategies come out. and then we try another one, which we might use your strategy next, right? Like, which is based on the distributive property, like multiply by 10, multiply by 5, right?